Okay, hi, I'm Andy Lester. I work out in McHenry, working for Follett, selling books to school libraries, and I've been doing this professionally since 1986. Back when a 10 megabyte hard drive was this big and sat as an appliance next to your computer. But along the way, I've been a manager and team leader, and have spent a lot of time out on Stack Overflow, a lot of user groups helping people out, and as I've hired people, and I wrote a book on how to get hired for programmers called Land the Tech Job You Love. How to plug that. And a lot of that is based on the experiences I've had of hiring programmers and the things that they knew and didn't know. And I've seen a lot of patterns coming up over time. Am I right in thinking that most of this room is relatively new to programming professionally? Like less than a year? Okay, less than 5? Okay, so a lot of these things are things that I've seen along the way and that I want to help, that nobody seemed to tell anybody, and especially fresh out of school. I'm going to give a longer version of this talk at CodeMash out in Ohio in January. And part of what I want to talk about here is, if there's anything in here you disagree with, please come up and tell me after the fact, because I know that things change over time, what colleges are teaching, and especially with boot camps these days. Boot camps seem to be all over the place in terms of what they teach. So, wrong way. Okay, so number one thing that I wish that they taught was tools of the trade, and number one is version control. And I've had programmers who come in who don't know how version control works at all. I've had to give explanations in how Subversion works. We actually still use Subversion because we have not had a reason to switch to Git, because we're not doing anything detached. We don't need the branching model. But this is such a fundamental part of what is part of programming these days that it almost seems criminal to not teach it in college. Who was taught version control in college? Okay, so you kind of, and so did everybody learn on the job? Okay. Number two, serious editing. Your editor is what you live in all day, and I've seen people who use Notepad for doing their editing. I've gone to job interviews where the head of the programming department was doing stuff in Notepad when he showed me what source code they had. I didn't take that job. Another one, learning to use the language for defensive programming. For instance, if you're writing in C, you have, come on, you little laser pointer. Oh, it's not going to work on the TV, is it?
No.
Curses. Anyway, so if you're writing in C, GCC gives you compiler warnings. In JavaScript, you have to use strict. PHP, even PHP has error reporting that catches a lot of things. Anything that you can do to have the language itself tell you things that might be wrong with your code as you're doing it, that is a huge benefit. And spending a lot of time on Stack Overflow, and especially in Perl, because that's my main language, so many people write into Stack Overflow and don't use these very basic tools that if they did, they wouldn't have to post to Stack Overflow. Okay, this is more of a mindset. Using make, using shell scripts, making things repeatable. We are humans and we should think, and the computer should do the work. And if you have to sit here and think about running a series of steps, to make a build, then that's inefficient. And we should, shell script should be part of what you do in life. Debugging, this is also a big mindset. Has anybody explicitly been taught how to debug a problem in college? Because this idea of I see a problem, I see something that happens, and I need to make it go away, and not knowing how to figure out what the root cause is, how to even make it repeatable. Just the idea of making a bug repeatable, of coming up with repeatable steps, being able to describe it, is something that people don't seem to learn in school. And that, to me, is as much a part of programming as knowing syntax, knowing third normal form for databases, any of that. And then also that, and then to go along with that is defensive programming. Once you start dealing with bugs over and over again, you start thinking about, how can I stop that from happening? And what can I do to catch that next time? This is sort of an extension of letting the compiler take care of it, but dealing with assertions. What do I do, what do I want to do if somebody passes a negative value to the square root function? Well, nobody will do that. Okay, that's great, but what if they do? That has to be answered, because users will do that. Users will do things wrong. Users will do things that you're not expecting because that's what their job is. Testing, thinking in terms of causing the problems, just thinking of, oh wait, this needs to handle negative numbers, for instance. This needs to handle the case of somebody who is not authorized to access this account. These sort of testing and coming up with the explanations of what you'll do when things go wrong is a further extension of this sort of mindset. We need to be learning about how to do testing manually. We need to be learning about how to be doing testing automatically in a way that scales. Once you're actually writing tests to make sure that this function does this and has this output, then you write that in a testing framework so that it can run over and over again. Because humans will not do that over and over again, but the computer doesn't care. How to think about efficiency. This is a big one that gets asked about in Stack Overflow, because some people say, well, is it more efficient if I use single quotes around my strings or double quotes around my strings? And the answer is, most of the time it doesn't matter, and so don't even worry about it. Because it doesn't matter how fast your program is if it's wrong. We need to think in terms of projects. We need to think in terms of releasing. We need to think in terms of actually making something happen and actually putting it out in front of people and letting the user get to it. If you're turning a homework assignment, this is probably the closest thing to school that the school has to giving the real world. Here, your project is you need to have this to me by a specific time. By an arbitrary deadline that is inconvenient, is training you for the real world there. Working with existing code. Everything that you do in college is this, right? They say, okay, here you're going to go write a function that does this, and then your first day on the job, you're going to do that. They're going to give you ticket 3481 and have you go fix it. And you need to be able to read other people's code. I would love it if college professors gave, assignment 1 is, okay, do this, and everybody turns in their code. And then assignment 2 is you have to swap with someone else and build on their code. Because that's what real life is going to be. You're not going to be working all by yourself. Clear technical communication. The ability to write a clear bug report for number 1. And this is an extension on thinking in terms of debugging, but the ability to say, this is what we want, this is what we don't want, these are the costs involved. Explaining to higher ups, if you do this, then it will take us this long. And letting people know what the trade-offs are. All of these things are business communication. And our job is to translate those business requirements into code. What can you do to fill in these gaps? I think these are two missing textbooks that every place ought to have for college students. One of them is Pragmatic Programmer, which is just phenomenal. The other one, Code Complete here, by Steve McConnell, is basically a construction manual for everything you want to do, and it's also this thick, and that's why I didn't bring it on the train. But these are absolutely indispensable for anybody who wants to write code for a living. Also, if you can get into open source, you're going to be working on these skills because you're going to be working with distributed teams, just like the world is going. You're going to be learning source control. You're going to talk about project life cycle. All of the things that we just talked about are things that are exercised in open source projects. And open source projects are also things that you can put on your resume as real experience for your next job. So thank you for your time, and you can follow me on Twitter because I post stuff like this all the time, and I write a lot of articles about this, and there's my blog down there, and I would be glad to have any questions or comments after this. Thank you.
Thank you.